It's 2005, Fort Worth, Texas. 12 massive cylinders came alive in perfect rhythm. 4,400 horsepower surged through steel veins. The ground shook, and every railroader watching knew they were witnessing something different. This wasn't the thunder of an EMD 710. It was sharper, quieter, more refined. It was the sound of change. The locomotive standing on that Texas test track was a statement. Cleaner emissions, lower fuel burn, smarter electronics. A 12-cylinder engine that could outpull EMD's 16-cylinder flagship without breaking a sweat. GE called it the Evolution Series. That day marked a shift in power, the moment when GE stopped following and started leading. This was the day GE silenced a legend, and the day EMD's empire began to crumble. Stay with us, because the story behind how that happened is even more unbelievable than the engine itself. It's hard to imagine a time when EMD wasn't the undisputed king of North American railroads. From the 1950s onward, their name was synonymous with power, reliability, and trust. Every major freight operator from Union Pacific to Burlington Northern ran fleets dominated by EMD locomotives. Their GP and SD series engines defined what modern diesel power looked like. The SD402, introduced in the 1970s, became legendary. Railfans still call it the backbone of North American freight, and they're not exaggerating. It was simple, rugged, and reliable, the kind of machine that could run 1,000,000 miles before needing a rebuild. It set the gold standard for what a locomotive should be. And while EMD sat atop its throne, General Electric was standing in the shadows, watching, learning, and biding its time. GE's early attempts were rough around the edges. In the 1950s, the company partnered with Alco, building electrical components while Alco supplied the prime movers. But when Alco stumbled, mostly due to the unreliable 244 engine, GE saw its opening. It broke off on its own and built the U-25B in 1959, the first true GE-built locomotive. The heart of that machine was the 7FDL engine, and while it wasn't perfect, it was the start of something big. Through the 1960s and 70s, GE was the underdog, the challenger brand in a market that didn't have room for second place. EMD's locomotives were everywhere, dominating rosters coast to coast. But GE didn't quit. It quietly kept improving, not by reinventing the wheel, but by making it run smoother, last longer, and pull harder. The real shift began in the 1980s. The railroads were changing. Deregulation and mergers were reshaping the industry, and suddenly, every operating cost mattered. Fuel efficiency became the new obsession. Maintenance costs were under the microscope. Reliability was non-negotiable, and that's where GE started to find its voice. The Dash 8 series, introduced in the mid-1980s, was the first sign that GE had learned the game. Powered by refined versions of the 7FDL engine, these locomotives offered better fuel economy, smarter electronics, and a new level of control for the railroads. The C408 and B408 were built for efficiency, and the big railroads noticed. Then came the Dash 9 series in the 1990s, the machine that truly tipped the scales. The C449W, with its 7FDL 16 prime mover, could deliver 4,400 horsepower with improved cooling, digital controls, and that unmistakable GE reliability that was once a dream. The wide-nosed North American cab became a symbol of modern freight power. Suddenly, the sight of GE locomotives leading long intermodals wasn't unusual, it was the new normal. EMD's dominance was starting to wobble. For decades, EMD's 567 and later 645 and 710 engines had carried their reputation. But as the 1990s rolled in, emission standards and new fuel economy targets began to squeeze every manufacturer. EMD's two-stroke engines, once their biggest strength, were now their Achilles heel. GE, on the other hand, had been building four-stroke engines since the beginning. The 7FDL wasn't perfect, but its design philosophy aligned with the new world of efficiency and clean power. The underdog had been preparing for this exact moment without even realizing it. And GE had the right engine. It had the right mindset. The company poured resources into electronics, computer control systems, and modular maintenance. And as a result, the Dash series locomotives were powerful, smarter, easier to service, and designed with long-term reliability in mind. By the mid-1990s, the numbers told the story. GE was selling more new locomotives than EMD for the first time in history. Railroads that had once been loyal to EMD, like Norfolk Southern, CSX, and BNSF, were now placing bulk orders for GE-9s. The underdog had become the favorite. Inside EMD's headquarters, the confidence that once bordered on arrogance was starting to crack. Engineers who had laughed off GE's U-Series in the 1960s were now facing an uncomfortable truth. GE was outpacing them. And while GE's 7FDL engine still had its quirks, every improvement GE made was another chip out of EMD's once solid armor. By the late 1990s, GE had stopped playing catch-up. It wasn't the scrappy apprentice anymore. It was the new heavyweight champion, waiting patiently for the old king to stumble. The early 2000s were a turning point in locomotive history. The U.S. Environmental Protection Agency had just introduced its Tier 2 emission standards, and for the first time, the rail industry had to face a new kind of pressure from regulators. Smoke, soot, and unburned fuel were no longer just part of railroading's charm. They were public enemies, and the clock was ticking. Every locomotive builder had the same problem: make engines cleaner and more fuel efficient without sacrificing power. At that moment, two names stood at the top: EMD and GE, both staring down the same challenge from two very different directions. EMD looked backward. Their 710G engine had been the workhorse of the 1990s, a 16-cylinder, two-stroke powerhouse that had powered the SD70 series across the continent. To them, evolution meant refinement. Add better electronics, improve fuel injection, tweak the turbocharger, and hope it passes the new standards. Their answer would become the SD70ACE, a locomotive built on legacy, not reinvention. GE, on the other hand, went the opposite way. They didn't want to polish an old design, they wanted to rewrite the rulebook. And so, GE began designing something new from the ground up. A clean sheet prime mover that would meet the new environmental rules and dominate in every measurable way. They called it the GEVO 12, short for GE Evolution Series 12-cylinder engine. It was unlike anything that had come before it. From day one, the goal was clear. Build an engine that could do more with less. Fewer cylinders, less fuel, and fewer emissions, without losing the muscle railroads demanded. To most people, the idea sounded crazy. How could a 12-cylinder engine possibly outperform a 16-cylinder one? But GE wasn't building on old assumptions, they were building on science. At the heart of the GEVO 12 was a massive leap in combustion technology. The engineers reimagined how air and fuel mixed inside the cylinders. By optimizing airflow, timing, and injection pressure, they achieved near-perfect combustion. More power, less waste. Each cylinder in the GEVO was working smarter. The result? 4,400 horsepower from a 12-cylinder engine. The same output EMD's 16-cylinder 710 needed 4 extra pistons to achieve. The turbocharging system was another marvel. Unlike older designs that struggled with lag and heat, GE's variable geometry turbocharger responded dynamically to engine load, delivering precise boosts where and when they were needed. It made the engine incredibly efficient and kept temperatures under control, even under brutal conditions. The electronic fuel injection system gave GE unprecedented control over every combustion cycle. Instead of relying on mechanical timing, the engine's computer could adjust injection patterns on the fly, maximizing performance at high altitudes, in extreme heat, or during heavy hauling. The result was an engine that passed Tier 2 standards. Compared to the old 7FDL, the GEVO produced 40% fewer emissions, used 5% less fuel, and lasted longer between overhauls. Railroads quickly took notice. The GE Evolution Series locomotives, beginning with the ES44DC and ES44AC, weren't just cleaner and smarter. Equipped with advanced microprocessors, real-time diagnostics, and modular components, they represented a new philosophy: reliability through intelligence. By contrast, EMD's SD70ACE program was struggling. Their older two-stroke design was being pushed beyond its natural limits. Meeting Tier 2 standards meant compromises, reduced reliability, higher maintenance, and complex emission after-treatment systems. Railroads that had been loyal to EMD for decades suddenly found themselves fielding warranty claims, breakdowns, and headaches. Meanwhile, GE was hitting stride. The GEVO 12 engine ran smoother, consumed less fuel, and delivered relentless power. It didn't smoke, didn't choke, and didn't falter when temperatures climbed or grades steepened. It was a predator built to survive in an environment that punished inefficiency. By 2005, the waiting was over. GE's new GEVO 12 was out in the wild. BNSF, CSX, Union Pacific all had their hands on GE's bold new weapon. They were hitched to mile-long freight trains, expected to pull 10,000 tons of cargo through blistering deserts, freezing plains, and punishing mountain grades. This was the real world, and the GEVO was about to prove whether all that engineering actually meant something. The first thing railroads noticed? Efficiency. These new 12-cylinder engines sipped fuel instead of guzzling it. Compared to the old 7FDL and EMD's 16-cylinder 710, the GEVO's appetite was shockingly lean. Every drop of diesel went further. For railroads managing fuel costs in the millions per week, that was a revolution. Then came the sound. Crews noticed it immediately. Smoother throttle transitions, less vibration, and a quieter cab. But efficiency and comfort alone don't win loyalty. Reliability does. And this is where GE started pulling away. The GEVO 12 was built to last. Its advanced cooling system, electronic fuel injection, and simplified design meant fewer breakdowns and less downtime. The 7FDL before it had always run hot, a constant headache for maintenance crews. But the GEVO? It ran cooler, cleaner, and longer. Railroads could stretch out service intervals, save on parts, and keep trains moving instead of sitting idle in repair shops. The early 2000s were brutal for locomotive manufacturers. New EPA Tier 2 regulations forced engines to run cleaner, but that often meant choking performance. EMD's SD70ACE had to fight against its own emission systems, dealing with overheating, power loss, and constant recalibration. Meanwhile, the GEVO seemed to glide right through those same hurdles. The difference was strategy. GE had built the GEVO from the ground up for this era. Instead of patching an old design, they rethought the entire combustion process. The result was an engine that could meet environmental rules without compromising horsepower or reliability. Soon, GEVO locomotives were proving themselves across every kind of terrain. In the Rockies, they muscled through steep grades with relentless torque. In the Southwest, they handled blistering heat without breaking down. And in the icy North, they started up on the first try while older models coughed and sputtered. Maintenance crews loved them too. With improved diagnostics and modular components, routine maintenance became simpler and faster. And then came the numbers. Real, undeniable performance data. Railroads reported lower fuel costs, longer time between overhauls, and better uptime than with the comparable EMD units. One BNSF report in the late 2000s even noted that GEVOs had a 30% reduction in unscheduled maintenance compared to their previous fleet. By the end of the decade, the verdict was clear. GE had done the impossible. They'd built a cleaner engine that was also tougher and more efficient. And that's what made it so dangerous to EMD. By 2010, railroads across North America had made their choice. The GEVO was the locomotive, the new benchmark for modern rail. The test was over, the results were in. And from that point forward, the rails would never sound the same again. By the dawn of the 2010s, the balance of power in American railroading had shifted permanently. The GEVO 12 was the new standard, and for the first time in half a century, the mighty EMD was struggling to keep up. In decades prior, EMD had ruled the rails with near mythic dominance. Their SD402 and SD70 series were legends, dependable, powerful, and built like steel fortresses. But when the new century brought stricter emissions laws and rising fuel costs, EMD found itself boxed in by its own legacy. Its 710 engine, once a marvel, was showing its age. When the two giants went head-to-head, the difference became obvious fast. Railroads began comparing data, side by side, and the numbers didn't lie. The GEVO burned less fuel, it met emission standards without needing constant adjustments, and it stayed out on the rails longer before needing repairs. Meanwhile, EMD's much hyped comeback, the SD70ACE, stumbled right out of the gate. Its emission system, designed to meet new EPA Tier 2 standards, turned out to be finicky. Engines overheated, fuel efficiency lagged, and reliability became a recurring nightmare. Railroads who bought early batches of ACEs found themselves grounding locomotives for fixes and retrofits, sometimes just months into service. By 2010, GE had the numbers that mattered most: market share. BNSF, CSX, Union Pacific, CN, and Norfolk Southern, all the major Class 1 railroads began standardizing their fleets around GE locomotives. The message couldn't have been clearer. The future of freight was spelled with just two letters: G and E. The GEVO didn't win through brute strength. It won through precision, through innovation. It was proof that you could outthink your opponent instead of outmuscling them. What made it even more poetic was how GE had played the long game. Back in the 1980s and 90s, when EMD still dominated, GE quietly learned from every defeat. The Dash 8s and Dash 9s weren't perfect, but they were stepping stones. EMD tried to recover, of course. Later iterations of the SD70ACE solved many of its early flaws: better emission controls, more reliable electronics, tighter systems. But by then, the damage was done. Railroads had already retooled their maintenance facilities for GE. Crews were trained on GE systems, and more importantly, the trust had shifted. You can fix an engine, but you can't rebuild reputation overnight. By the mid-2010s, GE locomotives accounted for the vast majority of new freight units in North America. The once invincible EMD had become a niche player, respected but no longer feared. The rivalry that defined modern railroading had finally found its conclusion. What began as a decades-long pursuit had ended with a quiet, decisive victory, one built on innovation, patience, and an unshakable belief in progress. This was the moment GE became king of the rails, and the day EMD's empire finally fell quiet. If you enjoyed this story of innovation and rivalry, subscribe, because next time, we'll dive into the engine that refused to die.